Under the classification of signals, the next classification is periodic and aperiodic signal. Periodic and aperiodic signals. Let me explain first what is periodic. Periodic signal. A signal x of t is said to be periodic. It is said to be periodic if it satisfies the condition x of t equal to x of t plus capital T for all t. For all t. If x of t equal to x of t plus t. What is t here? T is a positive constant and the signal is same even after the addition of this positive constant to our existing small t. Suppose if this condition is satisfied at t equal to some t naught, the condition is satisfied even for t equal to 2t naught, 3t naught, 4t naught, etc. nt naught. Means the signal will repeat at regular intervals of t naught. That is called periodic signal. Okay. So now what is t? Is called the fundamental period. As the signal is repeating after every t, t is called fundamental period. And the fundamental frequency is f is equal to 1 by t. You know the units are hertz, here the units are seconds. And the angular frequency omega, you know the angular frequency is omega. You can write it as 2 pi f, which is nothing but 2 pi by t. What are the units? Radians per second. Okay. Now let me draw the periodic signal. One example for periodic signal. This is your periodic signal. This is called the period. This is called the period. And this is from this to this it is t. So it will be your 2t. It will be your 3t. Okay. So what is the name of this signal? Pulse train or square waveform. So if you observe the signal, it is repeating after the interval t. Okay. So this is one cycle and this is another cycle and this is another cycle. The time in that cycle is called period. Okay, then what is aperiodic signal? What is aperiodic signal? A signal x of t is said to be aperiodic if it does not satisfy x of t equal to x of t plus t. Means if it has no value of t which can repeat the signal, that is called aperiodic signal. Or simply I can say aperiodic means x of t is never be equal to x of t plus t. That is called aperiodic signal. This signal. This is a simple pulse signal. Pulse signal. This is the pulse duration t. Here the signal is not repeating. Okay, means it is not satisfying the equation x of t equal to x of t plus t. That is the reason it is called aperiodic signal. Okay. This periodic signal and aperiodic signal concept is for continuous case. Let it be for continuous case. Then I'll see the definitions of periodic signal and aperiodic signal in the case of discrete. A discrete signal is said to be periodic. A discrete signal is said to be periodic if x of n equal to x of n plus capital N, where this capital N is called fundamental period. And the signal will repeat after every n. N take like n0, 2n0, 3n0, etc. and n0. The fundamental frequency in the case of discrete is represented by omega, and that is 2 pi by n radians. So this is about periodic signal. Discrete signal or discrete sequence is said to be periodic if it satisfies x of n equal to x of n plus n. For aperiodic, the condition is x of n is not equal to x of n plus n. Means the signal won't repeat after n number of samples. That type of sequence or signal is said to be aperiodic signal. Coming to the example of periodic, see the sequence? At 0 also we have sequence. this total is up to this. Up to this it is called period. So what is capital N here? 1, 2, 3, 4, 5, 6. If we extend this signal, it repeats again. After n equal to 6, it repeats. Suppose if we extend this like this, you're going to get the signal like this, like this. So what about the sequence here again? What about this period again? Again 6. Okay? Means the signal is repeating after every n. So that is called periodic signal or periodic sequence. Suppose if you go for aperiodic, example for aperiodic, this is n, see the sequence, it won't repeat. If you see the aperiodic signal or aperiodic sequence, the signal or sequence won't repeat. Okay. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.